Well, this is Desiree Dubonnet from Immune. We're going to be talking about the senses, and I believe that there's 9 of them we're going to have to study. Now, the old idea was that there was sight, smell, taste, touch, hearing, haptic, the sense of touch. That these are our senses that have been able to us to relate to the world.
Receptors in the skin provide us with tactile information about qualities like the position, shape, texture, pressure, and movement of things we come in contact with.
In addition to the typical sense of touch, we also have the other senses, the known senses, affecting our emotions. And all the senses will be affecting the emotions, even the new ones we're proposing. Sight, the classic, vision, to be able to see photons, electromagnetic radiation. Hearing, taking vibrations, subtle, tiny little vibrations, converting them into messages inside the brain. Then the sense of smell, the sense of taste. They're very, very similar. And they work on electromagnetic sensing, voltammetric detection of different substances. These sense organs give us information that goes to the brain, which actually interprets the information. These are just sensors. But speaking of sensors, we have to recognize that there's a sense of balance. It has its own organ inside the ear, and it's a separate thing from hearing that allows us to sense balance and be able to walk, play basketball, football, all the different sports. Here we have a man trying to learn balance blindfolded. Now we get a lot of cues from our eyes. Now when the cues from our eyes are gone, very difficult for him to maintain that balance. But yet there is a deep sense of balance. And after enough practice, he's going to be able to develop that. He's going to be able to get over the link, the loss of the eyesight, and then using that sense of balance in the different parts of the inner ear. It's a separate thing from hearing, separate thing from vision. He will be able to develop balance because it is a separate sense. It has its own sensory organ, different from hearing, different from sight. There definitely is indeed a circadian rhythm sense that's based on the pineal gland. It is light sensitive, but it's not really an eye. So it doesn't really have a vision that it focuses, but more of an intensity. And it develops our daily rhythm as the sun wakes us up in the morning, sparks of different hormones, and creates a whole idea. So there really is a circadian rhythm sense. And yes, the pineal gland has its own type of light sensor, different than the eyes. It really works on a different type of frequency, different types of everything. So it's a separate sense, the circadian rhythm. It has to be dealt with as a new sense. An electrosense. This has been well documented in many, many fish, most importantly the shark.
Now the shark was first found to have a system in his nose to be able to detect electrical phenomena at a distance.
All sharks are attracted to the weak electromagnetic fields of their prey, but it's thought that the hammerhead's extra-wide head shape gives it an especially sensitive detector. To find out just how sensitive, Steve is using electric currents to create these fields and see what field strength they can detect. The circle of cable on the left has a current running through it, while the one on the right has none at all.
How minor is this current we're talking about? This current that you're putting in here?
Right.
How minor is it?
What I'm applying right now is 7.7 microamps, 5 nanovolts per centimeter, 5 billionths of a volt per centimeter.
It's an incredibly small figure.
The way to think about that would be to take a standard flashlight battery and stick one lead in the water in Boston, and the other lead in the water in Miami. And a shark swimming directly between those two leads would be able to detect that minute amount of current flowing between those two leads.
Just a little torch battery.
That's right, that's right.
And that's about 1,500 kilometers or so.
Right, what's that? Yeah. It's tiny.
That's amazing.
Yes, an amazing display of the electrosense.
Even though they look identical, the target on the left attracts all the shark's attention. So Steve knows they're not attracted by visual cues, just a tiny magnetic field.
But there is definitely an electrosense in the human being. It is very weak, but there is an electrosense. It's also coupled with the nose, but still, It has to have something to do with some other different ideas, and I think that we have to include it as its own separate sense.
We now find out that that same type of electrical analysis, that electrosense that we all have, as Spidey tells us, we all have an electrosense. That electrosense is in the human being been translated into the nasal pharynx and also all the different cells of the body. But the nasal pharynx has the most intense collection, because this is where the shape receptors are. Now for the shark living in salt water, there's a direct electroconductivity between the substances that have an electrical field and the shark's nose. However, in air, as we live in, the air is not electroconductive. So thereby we have taste sensors in the tongue and nose and shape receptors that allow those things to come in and touch.
And then we would be fools to not recognize the ESP, or the sixth sense that many people have talked about. It is undeniably a factor that it exists. It can be well documented, even though it is not as reliable. Reliability is not really the basis. In fact, it only takes one white crow to prove that there are white crows. We don't have to find a whole flock, or what they call a murder of crows. We don't have to find a whole murder of white crows to prove that there is a white crow. We only have to have one. And there is definitely many evidences for the ESP sense.
The kids could still read and write using these blindfolds. All doubt among the crew would be extinguished.
Okay, I'm going to write something on this paper, and you'll tell me what I wrote, right? Mm-hmm. Okay, here we go. It's going to be one word.
Okay. Light.
That was so fast.
Can I write something?
Yes, you can. Actually, can I draw something and then you redraw it?
Mm-hmm.
Okay. Okay. I don't know if you can tell what this is.
Car.
What? I didn't even point it at you yet.
The ideal age to learn is between 5 and 12. Nicholas says after 12, the left side of the brain, both critical and logical, interferes with the spiritual lessons.
And run down your arm, jump off your fingers, and go and touch something in front of you. Feel it with your energy, anything you like. And then come all the way back in, run up your arm, back in your head.
I'm confident. I can do anything.
And I can do anything. You might say God was fair to children. He gave them the power to believe in themselves without any doubt, making it easy to tap into their full potential. Walt Disney said, "The problem with the world is that too many people grow up."
These children are taught to not depend on their vision, but to actually expand their mind using extrasensory perception that they don't have to quite understand in order for it to happen. So even completely 100% blindfolded, they're taught to develop these techniques.
Can I read blindfolded?
So with this in mind, I welcome you now to study with us about the 9 senses and to look at different things and how we can measure this, treat it, and learn about the sensory organs for our people. So I welcome you to our course on the 9 senses. All of our senses are quite complicated. Now let's look at the sense of touch, the haptic sense. Tactile.
Merkel's discs are slowly adapting receptors that have very small receptive fields and high spatial resolution. They are especially dense in the fingertips and are best suited for processing information about shape and texture. Meissner's corpuscles are rapidly adapting receptors. They have relatively small receptive fields, but their spatial resolution is inferior to that of Merkel's discs. They are especially effective at transmitting information about movement between the skin and another surface. This can be used to sense texture and to detect if an object is sliding past the skin, which is important for maintaining grip. Pacinian corpuscles are rapidly adapting receptors with very large receptive fields. They are thought to be most effective at transmitting information about vibrations objects cause when they are contacted or grasped by the hand. This information may be important for the use of tools. Ruffini's endings are slowly adapting receptors with large receptive fields. They are poorly understood but seem to respond most to skin stretching, like what would occur with the movement of the fingers. This information might be especially important in generating awareness of finger and hand position.